Right, we all ready? Hopefully everyone's back from lunch now, both in the room and on WebEx. So in this next session, we're going to talk about a customer case study. And this is not a marketing set of slides. This is a real world. This is what we did. These are the problems that we had. And to talk through how we resolved some of the things that we had and still have in some cases. So Vince Milotto is here from, well, you work for Kyndryl, but you work on the legal and general account. And we'll look at how IWA was implemented within legal and general's infrastructure. Now we'll refer to everything as IWA rather than IWS. Does everyone know the difference between the two? Licensing, that's the only difference. So IWS is PVU, IWA is per job. So whenever you see any documentation from IBM, and you'll see the two acronyms interchangeable, from a product point of view, it's exactly the same code. It's only the licensing piece that's different. And marketing. You know, all the stuff we're not going to...
IWA is actually the brand name as well. So when we try to refer to it in general, we try to use IWA. So just if you see it, it's the same.
I like this slide. Claire put this together. And everyone that's seen it so far goes, ah. But who are legal in general? Now, most of you in the room will have heard of who they are. They are a multi-billion pound company that does insurance. And in our case, the project we're working on, it's pensions specifically. So Legal & General are the biggest pension provider in the UK. And the way it's termed internally is that they are the second largest payroll in the country. Only the NHS are bigger, because that's what a pension is. So those of you, I take it everyone knows what a pension is. Does everyone have a pension? It's all company pensions, I guess. So when you retire, which for me, hopefully it's one day very soon, what happens is that your employer stops paying you and your pension pays you instead. So it's like every month you get money, just like you do on payroll. And that's why the part of Legal & General that we've been working in is classed as payroll. So they're a long-standing organization and everything's been done on the mainframe. So the pensions application was a monolithic application that has been around for 60 years, something like that. Come on. So the project in case was called the AIOPS Modernization Project. And as you can see from the slide, Asset Liability Payment Service, AIOPS, is this payroll application that people that have retired get paid by. And the project itself was to decouple this monolith. So it's 40 different pieces to this massive application. The first two parts were broken off as part of phase 1 and moved to Microsoft Azure Kubernetes. Microsoft did an absolutely fantastic job in persuading Legal & General to move to their cloud platform.
What were they using before?
They're still using IWSz.
Oh, right, so they were already...
Yeah, so everything was done in in IWS on the mainframe, this part of the application has been broken off, moved to Kubernetes, and scheduling was required there. But as we'll see from the presentation, the batch spans both environments. In fact, it splits between 3 environments.
Is that simplification?
Yes. Okay. So the actual application itself was rewritten by TCS as a native Kubernetes application based on WebSphere Liberty, talking to Microsoft SQL database behind it. And everything was rewritten within the application and only available via REST API. And that's what we had to integrate with. So the IWA requirement was to integrate with the mainframe, run REST API jobs against API Manager, which is part of Azure Kubernetes, which then talks to the backend AIOps application. And this is a multi-stage project, so other applications will be broken off, moved across to Kubernetes, but what they have also realized or decided on is that not all 40 parts of this application can go across to Azure. Some will remain on the mainframe moving forward. So this is a project that will run and run. We started the project back in September 2022, and then it went live in August this year. So this is a customer that is live today. It's working most of the time. It does what it's supposed to, doesn't it, Vince? Yeah. You were supposed to say yes. Right. Okay. So in terms of the requirement, firstly, and probably the most important thing was seamless integration with the existing scheduler on the mainframe. And that's really why IWA was chosen, was the fact that we can create remote workstations, shadow jobs, so that as jobs run on the mainframe, they can, the next piece can run on distributed and then go back to the mainframe and continue, and vice versa as well.
Did you encounter any issues with shadow jobs specifically?
Yes.
Is the realization aware of it?
Yes, but a lot of the issues, because the mainframe side of things were upgraded to 9.5, a lot of those problems went away. There are issues in terms of, there were issues in terms of when the shadow job starts, which one it actually binds to and things like that. But once we got over the logic and kind of realized how actually it needs to do this, once those changes were made, everything worked. And that part has actually been fairly smooth, hasn't it?
Yeah, I think most now we've done a schedule application, but we dynamically try job stream in IWA. You've got shadow jobs coming from IWA to the mainframe. We're still having issues with binding. Most of the one, if the streams part of the plan, then it's into
What version of IWA was this written on?
9.5 mainframe, 10.1.
10.1.
Yes, because we're on Azure Kubernetes, and at the time, that was the latest version. But that's the thing, when you're in a containerized world, you go to the latest version, because that has all the fixes and help charts.
I know you said you were Z-site, which we started, you also have D-site, an existing D-site as well. What was the
Mainframe, and then we had we've got about 100 full-time agents. So basically, the jobs that rank full-time agents to be moved into.
so
And then, as we were progressing, there was this bright idea of, well, this is the first application to go across. There might be other applications, not just on the pension side, but other parts of the business that may want to use this strategic platform moving forward. So let's create IWA as a shared service and then connect to the pensions side of things. Because each of the different applications or business areas have their own Azure clusters. So there's a cluster for shared services, which is where the master is. And then there's a cluster for pensions, which is where the agents are. The other requirement, which we'll look at in a lot more detail, is everything has to be secured using SSL. So SSL from the mainframe to distributed to the agents to our application manager. Different SSL certificates for absolutely everything. So the SSL certificate management side of things in IWA was challenging. I think we're going to put an RFE in for how to improve or ask for improvements on that side, because the whole certificates management side of things proved to be difficult. But we'll go through that in more detail. Is that Nigel?
Yeah, hi. Just clarify, where's the master? Is it still in the mainframe or is it in the cloud?
So the mainframe, the Z controller is still its own independent environment. We have a master and a backup master in Azure Kubernetes and a shared service cluster talking to the mainframe. So it's peer-to-peer. And then we have dynamic agents talking to the shared service master, all secured using SSL. There's a diagram on that, so I'll show you in a second. So the first thing we had to do was a proof of concept. So the mainframe side of things, and now the IWA piece is run by Kyndryl. The IWA master is hosted within shared services, managed by an internal group within Legal and General called Group Tech. And then the pension side of things is managed by TCS. So you've got 3 different organizations managing different parts of it. And that works really well, doesn't it, Vince? Only kidding. So as part of the proof of concept, the deployment of IWS is done through an Azure pipeline. So we have the Helm charts that we take from GitHub, load them into an Azure registry, make changes to the values.yaml file, and then deploy into the Kubernetes cluster. In this diagram, in the proof of concept, we had 2 DWCs and master and a backup master. In the final version, we took out one of the DWCs because it was redundant. It wasn't really needed. Because they are pods, if anything happens, the pod just recycles and it comes back up again. All accessed through an ingress, which again changed to just be a load balancer. So users would log in and see the batch through Azure, and then the administrators would deploy all of the infrastructure through Helm charts and an internal container registry. So we had to prove all of that worked. And then in terms of the agent side, we have an agent and the AIOps application, which turned out to be an API manager within its own namespace as well. So we had to prove that not only did the infrastructure work and was robust, but also that the jobs ran against API Manager and we got the right results back. So in terms of the batch, what Marco was talking about before, where the new REST API job not only makes the command, but then waits to see what comes back. None of that existed when we put the batch together. So we had to have separate jobs for the submission and then polling to see what happened. And then when it finished, then we could complete. And if it then went back to the mainframe, we then released a shadow job and it then continued from there. So all of that had to be built. And everything talks to a managed Azure SQL database. So that was a service as far as IWA was concerned. We were just told, this is the host name, the port, and here are the credentials. You don't need to know anything more than that.
So the entirety of the master infrastructure is all on Azure?
All on Azure Kubernetes. All of it.
And you've got no domain managers, just the masters?
Yes.
So do the agents below it in the application namespace, they talk to those masters?
Yes, directly.
All right.
So there's no domain managers. There's everything is, master to agent, because there aren't a huge number of agents yet. But as the shared service grows, then the number of agents will increase.
And would you consider introducing domain managers, or does the architecture of cloud mean you don't need to do that?
No, what we have introduced or catered for is gateways. So if you've got, say if this is on a completely separate cluster, which is what it ended up as, if you've got multiple namespaces, you would have agents talking to a gateway agent, and then the gateway agent talking to the master, because these are all dynamic agents.
Okay. Yeah.
So in that way, all of the the jobmanage.ini files would have the gateway as its rather than having gateway as local host, it would have it as the gateway machine, the gateway pod, and then it would go to the master.
Right.
And then that was raised as an RFE, as an idea, because it didn't work on dynamic agents within Kubernetes, but now does at 10.2.
Right. And how many agents are there, just to give us an idea of scale?
It's a handful at the moment.
Right, okay.
So it's pretty small because only this one piece has gone so far.
Yeah.
Okay. So in terms of the requirement for IWA, once the proof of concept was done, we looked at how to create the overall solution. And the first thing we had to say to the Kubernetes administrators, and I found myself chanting this quite often, was that IWA is a stateful set application. Not stateless, which is what everyone thinks, oh, we want this and it has to be stateless. No, you can't do that. IWA is a stateful set application. What does that mean? Well, what it means is that it needs volumes. It needs its own file stores. It doesn't do everything within the pod, and then when the pod refreshes, everything continues. There's data written out to data volumes that must remain persistent, both on the master side, you can imagine, Symfony file, but also on the agent side as well. So where you've got, the message files, all those sorts of things, as well as certificates, all those sorts of bits and pieces, all have to go to persistent volumes. So IWA is a stateful set application, both for master and for agents as well. So what needs to be defined is a storage class, within Kubernetes. So the underlying storage piece has to be set up in advance. And then from the Helm chart, you call storage class equals, and then whatever that name is, and then it builds everything underneath for you. If you don't specify, and in the default Helm chart, there is no value, in which case it uses the default storage class and builds it all in there. So again, one of the lessons learned was, well, one of the expectations was you modify the Helm charts, deploy them, and it works like magic. Anyone that thinks that is daft, quite honestly. There's a lot of stuff you need to do under the covers to make sure that A, it will work, and B, that you won't lose data, because it's as a serverless infrastructure, it's ephemeral, which means that the underlying infrastructure can go and it rebuilds itself. And you have to make sure from an application point of view that no data is lost. And everything is controlled from within your Helm chart. So because we can only set the storage class within the Helm chart itself, everything underneath. So you have a storage class that has a persistent volume claim and persistent volumes that link up to it. All of that has to be done in advance. And both from a master and from an agent point of view, when the pod starts up, it mounts its volumes, just like you would do if you had a virtual server with an NFS mount. That's probably the closest analogy to the way IWA works within Kubernetes. Okay, so in terms of the environment, so we'll start kind of top down. So there are 3 environments. So we have dev, pre-prod, and production. And in each of those, we have a mainframe instance. We have an IWA master, IWA backup master, ALPS IWA agent, and the ALPS application itself. So we can upgrade in dev. Well, we spend most of the time breaking dev, fixing it, and then applying those fixes to pre-prod and production. The other thing that's maybe not unique, but certainly well worth talking about, is when is pre-prod more like production? In legal and general terms, pre-prod is probably as important as prod. And the reason for it is because we're talking about pension payments. So the application has to do forecasting. So they have one of the sub-applications within it is called time travel. Not Doctor Who. What they do is they wind the clock forward. They say it's the 1st of April, run the pensions or run the pension reports. Because a lot of the stuff that goes to not just the individuals that get paid, excuse me, but a lot of people are paid through either companies or independent financial advisors and all these sorts of people who are in the chain for pension payments. So all the information that they get has to be accurate. So each quarter, each month, they use this time travel application to make sure that what they're generating next month, next quarter, is actually correct. So pre-prod, which is a mirror of the prod environment and has all of the same jobs. In fact, it has more jobs in pre-prod than they do in production because of this time travel application. Excuse me. And then you've got prod, which is where the magic happens. And each month, people get their pension payments. So one of the interesting facts that we learned throughout the project was that there's somebody that gets a considerable amount of money each month. That they give us the information on who gets the most money, and it's yes, him. And then on the side, but just as important, is the ServiceNow integration. So everything is controlled through ServiceNow. So as a service, because it's shared and all these sorts of things, most of the people access IWA information through ServiceNow. You've got all the support people that get the events. So it's the ServiceNow event manager. So we saw this morning incidents being created, but ServiceNow has its own event manager. So information goes to the event manager, which does the filtering, correlation, and then generates the incident, rather than us doing a one-to-one. So a job fails, an incident is raised. It's not. Job fails, event happens, and then information is correlated with it, and then an incident is created. So we have to provide a lot of information as part of the event action that then goes up to ServiceNow. And that's why I was asking about going back the other way, because the ServiceNow development team have interfaced to IWS and they pull off all the job and job stream information and include that as part of their reporting through ServiceNow. So the line of business people get a report to say this is what the application's done, this is what batch has done, underlying infrastructure, as a single report. And they're pulling all the batch information out of IWA, straight out of the database. So 3 environments, all pretty similar, including a mainframe and ServiceNow. Okay, so in each of those environments, we have the following setup. So we have the mainframe, OPC master, connected to master domain manager and a backup master, single DWC now, because we got rid of the other one, and then talking to the agent side. But as you can see, the way IWA works within a Kubernetes environment, and let's face it, IWA as a pod is pretty much a different product to what you would do on a virtual server. Functionally, DWC, all that sort of stuff, once it's up and running, exactly the same. Looks great, you wouldn't notice the difference. But under the covers, as pods, it is pretty much a different application. So what happens is that you have services, and the master connects to a service, which is an IP address, name or an IP address. And then if the master fails, the backup master inherits the service so that it can continue talking to the agents, the users continue talking to the master. So where you've got your automated failover, you've got your master and your backup master running, but when the backup master takes over, it inherits the IP address or the label to then connect to the service. And there were quite a few issues with that. You wouldn't believe that Vincent's only 25, would you?
Mainframes only connecting to the master for shadows, is it?
Yes.
So the mainframe's got 50 FTAs underneath it, and it's connected to the master of IWA. Some jobs run with the FTAs, some jobs synchronize between IWA and master of IWA. And then you've got jobs which run on the dynamic agent. There's also now, there's an FTA which is under the OPC master, which also has a dynamic agent for time and travel. So it's connected. So the dynamic agent is connected to IWA, but the FTA is still connected to the master. There's a lot of files too. Yeah. Not a big file.
The issues that you described, were they related to the products, either be sort of limitations or defects or workarounds you had to find? Or was it environmental issues being new cloud to
Because it's in a pod, problem determination is very hard. You can't do ping, you can't do lots of commands that you do PD aren't there. So that's one of the main issues. So you have to look at message logs, maybe guess there's a firewall entry there or something wrong, or you have to get the firewall team involved. And also there's a lot like the backup, when it fails over, sometimes it works, sometimes it hangs. And we're still looking at, it's not as reliable as it should be.
But a lot of it is to do with the underlying infrastructure. It's the way it's taken over, because there's a slide on it about labels, the way it takes it over. So you have to, that's why getting the underlying configuration is really important. I mean, we've had issues where the whole environment can be wiped and just re-provisioned. Yeah, the whole thing. The whole cluster comes back. We had that the other day. All the IP addresses changed, which meant that none of the firewalls worked, and that was an IWA issue.
When we used the latest version of the help chart, that didn't work. So we had to go to 161 and then upgrade for it to work, which again you shouldn't need to do.
What's the benefit of putting the master into the cloud?
Well,
I think we had
there was no technical benefit. It was the strategic direction the business was taking. That was a given before we kind of even got involved in the project.
I was going to ask actually, if there's a technical benefit to moving to the cloud, or is it because the industry's new cool thing?
you get a console. Obviously, we would have a console. You use a console, but again, there's no choice because we have to use REST APIs and we have to use containers.
Yeah. The thing for us was that the AIOps application was rewritten into Azure Kubernetes.
Right. Well, I get
So
that. I get
jobs.
that. It was the master backup to be
Not on virtual servers.
Yeah.
Because there weren't virtual servers available. It was a requirement that it would be Kubernetes day one.
But that's because the company elected for that.
Yes.
And you're saying your master was there, but then when it failed over, the backup master retained the master and its IP address and everything.
No, well, what it does, it inherits the service.
Right.
So what you have in Kubernetes is you have a pod IP address, and then you have a service IP address. So the pod IP address is internal. The namespace manages all that. So any external connection coming in or going out goes via the service.
For example, app serves down. It's then 5 minutes, it automatically back up. It will make it fail over to the backup. Most of the time, sometimes it can fail over.
Yeah, I mean, yeah, I'll caveat that because we did see problems where the backup master, when it flipped across, Kubernetes then came back and said insufficient resource to do it. And the whole thing hung because this service, the master service LB, had 2 pods connected to it at the same time, the master and the backup master. Which is a valid configuration for Kubernetes because, as the name suggests, load balancing is something a service does. So if you had a web server, you could potentially connect 2 pods to it and have half your users on one, the other half on the other. But it's not a web server, it's an application. And the application requires the DWC to connect to only one master through that service. And then the other thing we needed to do was rewrite all of the jobs that were on that part, the jobs associated with those modules as REST API jobs. Hand up. Okay. So where do you start? So for the Kubernetes version of IWS, you go to the Workload Automation site on GitHub, and that's where your Helm charts are, but also the images. And what the images do, under the stables subdirectory, you have compressed tar files which contain all of the Helm charts. So when you deploy using Helm, you say, this is the stable version that I want. These are the changes that I want. So as new versions come out, you just tell it the stable version, and chances are you don't need to change the changes because that will stay the same. So as new versions come out, the theory is to deploy a new master, an agent, whatever. As new versions come out, it's as simple as stating what the stable version is with the changes, and it will just do it for you.
So going back to what we were speaking about before lunch, and the time it takes to upgrade our service, is if the future is cloud tech, and we were to put our masters and things into cloud and containers, would that theoretically mean that those upgrades are far more straightforward?
Yeah, you can roll forward and roll back very easily, just a single command. Underlying database, different matter.
Yeah. Yeah.
Testing different.
Yeah. So in order to deploy the Helm charts, you need access to the containers themselves. And that's done through the IBM Container Registry via a token, and each company will have their own unique token. So whoever manages Passport Advantage for you as the primary technical contact can log in using their IBM ID, and it will tell you what your company token is. You can then use Docker or anything else to pull that container to your local machine or to your own internal repository, and then deploy from there. Now, the Helm charts, for licensing reasons, you can't just say deploy. If you went and got your containers, got the vanilla Helm charts and said deploy, it wouldn't work. And the reason for it is because you have to accept the license terms. So there's a statement within your values.yaml file that says license, and the value is not accepted. You have to change that. One of the changes you have to make is accepted. So you're explicitly accepting both the license and the license terms from IBM. And then you hold those containers within a private registry. You modify the values that you want and then deploy them. If anyone's thinking of doing IWA on Kubernetes, go to this site, have a look at the Helm charts and understand what the Helm charts are doing. It's not just the chart itself, there are templates that come with it that will deploy your services, will look at your SSL side of things. Understand all of it, because if you come up against problems, that's the first place to look at. So if any of you are thinking, well, this looks like something completely different, I've never done this before, this might as well be called another product. You're absolutely right. It is. I mean, it's so different to what most people are used to on the distributed side that, yeah, it's.
Well, quick question. So this is what's running on Azure in your
Yes.
environment. What about the agents?
They're all in Azure.
But
In a different cluster.
But they are not installed with this.
Yes.
So this takes
Yeah.
care of the
So what
agents.
happens is that all of the containers are held within a private registry within Azure. Both clusters have access to that registry. They have their own set of Helm charts that they then use to deploy.
So there are certain namespaces, you're separating them by namespaces though,
Mhm.
you showed in your architecture.
Yes.
So where are you giving it the configuration on this agent needs, we need one agent in this namespace or
That's all done by
it's
the
in the
helm chart.
configuration?
Yeah.
Okay.
So when you do that, when you run the helm command, you can say which namespace to put.
There is an agent in the master cluster as well, but we don't use it. So we run a few jobs in there. You can run. It was decided to add a separate cluster to run the AIOps agent. I suppose you could run the agent in the same cluster.
Yeah, you could.
Make it easier. But I think for security purposes, it was agreed to build a different cluster.
So if you get your values.yaml file right, then yes, deploying is really easy. Everything comes up, the pods start, you connect to the DWC, you can see the master, it connects to the database, all those sorts of things. But getting those values right is the difficult bit. And getting your SSL certificates right. Okay. So, yeah, IWA works completely differently within the containerized world to your virtual server world. The root process on all of your pods, and that's the other thing, is that when you look at the master, you look at the DWC, and you look at the agent, they're actually running the same script, but just with a different value. So again, one of the things that I think needs to take place is actually document how it works, the flow within the containerized world, because the WA start.sh process script is massive, and it does a lot of things, and most of which is undocumented. So the pods themselves, that's the main piece that changes between a master DWC and an agent, is just its initial step. And then to get the difference between a master and a backup master is within the Helm chart, you've got a value called replica set. So if you set the replica set to 1, you just get a master. You set the replica set to 2, you get a master and a backup master. And when the first one starts up, it says, there is no master, I'll become the master. And then when the second one starts up, it says, there's master already, I'll be the backup master. And this root process, the WA start.sh, then starts and then kicks off 2 other scripts, which updates everything. So this is where your SSL certificates come in, for example, and then you've got the common environment stuff. So this is taking information from your Helm chart. So when you load the Helm chart actually loads that into Kubernetes. How does it get into the pod? Well, when the pod starts up, this WA common.sh queries the Kubernetes values and loads those into the pod. And then to debug what's going on, everything is written to the Kubernetes logs, apart from the install log and various other bits and pieces. So you still need to look in 3 or 4 different places to actually get the full picture of what's going on. And we've touched on this already, the documentation is not great. In fact, the majority of the documentation for this is just the README in the GitHub repository. So the bit on SSL certificates, for example, is probably 1 paragraph, and then an example of what the file should look like. That's it. You've got to figure the rest out yourself. Okay, labels. So one of the processes are kicked off by this WA start is the labels process. So when it starts up, it reads the labels, the Kubernetes labels, and then decides which service to connect to. So in the initial step, when the master starts up, in the WA common.env environment, it decides whether it's master or backup master. And then the pod tells Kubernetes which one's which by binding to the right service. So those services need to be set up. There are templates already within the charts to show you the services being created. But as we found, if you have a master and a backup master, it doesn't work properly. We've had to set in order for the labels to work properly, they use a Kubernetes selector. And you have to set the Kubernetes selector to WA server type equals master, and then only the master will bind to it based on the label. If you don't, both will bind to the same service. Unless you set up the services beforehand and you've spoken to the Kubernetes administrators and said, this is what we need, these are the reasons why, and can you add this service selector? If you do that, then it works perfectly straight off the bat. Okay. And again, labels is something that is constantly monitored. So it goes around a loop. And that's why when the master disappears and the backup master changes, it then changes its own internal label to then bind to the right service. And that's how it works automatically, failing over and failing back. Okay. Now the painful one. SSL certificates. Who uses SSL today?
Jonathan's never had any issues with that. But it works perfectly. There's nothing wrong with it. Not a few WebEx calls and many months didn't solve.
So, in Legal and General's environment, they use SSL certificates for everything, apart from the connection to the database, because it's a managed SQL service. It's within the same cluster. It wasn't deemed that an SSL certificate was necessary, but everything else. So, mainframe to master, DWC to master, master to agent, agent to ALPS application, all use SSL, and each certificate is different and generated by different people. Yes. The other thing is that when you generate an SSL certificate within Kubernetes, it's held as a secret, and the way it knows it's an IWA certificate is using a label called WA-import true. So when the pod starts up, it looks at all the secrets, sees which one says WA-import true, and brings those in. But it's completely different to the way it works within a virtual server world. But you still have the same tools that you use. So things like OpenSSL as a command, key tool, are all available within the pod. But the thing to remember is that if you use key tool, for example, to load a certificate into the pod, when the pod recycles, that certificate's lost because it's not held as a secret. Just makes it a bit more fun. So, you know, you have to make sure that it's right. The other thing is when the agent talks to the ALPS application, it uses an SSL certificate. And because it's REST API job, has anyone seen the PKIX certificate not known error? Yeah? That's because the SSL certificate isn't loaded into the workstation, the agent, and that's the most commonly missed thing. So the way SSL works, for those on the call as well, is that when you make a connection, the SSL client talks to the server and says, hello. The server talks back going, hello back, and here's a public certificate. The client then looks in its key store and says, is that a valid certificate? If the answer is yes, then it responds to the master, back to the server side, who then encrypts that certificate using its private key. And then communication can take place, it's secure, it's great. But if you don't have the SSL certificate in your key store, it's never going to work. And that's the bit to get right. Okay. Oh, yes, that's the other thing in the Kubernetes world. Because it's loaded as a secret, that secret is only valid for 90 days. And after 75 days by default, it cycles. And if you're between clusters, you've got to keep that in sync. If you don't, then one side thinks it's X, the other side thinks it's Y, and they stop working. We've had that as well, haven't we?
Yeah, hopefully we can automate that. There is a secret that if you place in both clusters, hopefully it should work, but we haven't proven it yet.
So at the moment, every less than 90 days, we're having to manually sync SSL certificates. Okay, and then on the agent side, talking to the API manager, it was deemed that SSL was not enough in terms of security. It's like, you're kidding me. Is this not enough for you? Is this not as difficult as you want to make it? No. So they introduced an additional level of security, which is called a subscription key. So you set up your SSL connection, that's at the transport layer. You then send your REST request, whether that's a GET or a POST or whatever, and then you have to add this subscription key in the header as an additional security mechanism. So it is very, very secure when it works.
Is that a TWS or is that just an infrastructure?
That was a requirement from the application. So this subscription ID is actually from Azure. So Azure generates it. And again, the subscription key has a primary and a secondary key, which are generated every 2 weeks, that we then have to import into IWS, update every job within the database, and then when that job is executed, make sure that the right subscription key is used. So we had to build the whole mechanism in order to make that work. And it does. That's been reliable, hasn't it? That's been, yeah. Touch wood. So in terms of the level of security within the environment, it's pretty much there. I can't think of anything else that's needed. But what it does mean is that the management of tokens, certificates, all those sorts of things, then becomes Vince's headache. Because some are 2 weeks, some are 90 days. Then you've got the certificates themselves, the timeout, and all this sort of stuff. So personally, I think the whole SSL certificate side of things, management of certificates, both within the master and the agents, needs some sort of tool to help customers. Because you've got the raw native tools, OpenSSL and Key Tool, but you then need to know how to use it. So as an IWS administrator, if you're using SSL, you need to be an SSL expert in order to use it.
Then we have to create dynamic schedules, which we basically run from the mainframe onto an FTA, which then runs a curl command, which dynamically creates a schedule in IWA using a token, which you have to generate from within IWA, make a master.
I'm coming to that one.
Oh.
It's just layers of complexity. It's kind of, oh yeah, we've done that. Let's make it more complicated. Let's make it more secure. All these requirements that just kind of, oh yeah, that's great.
What's the monitoring done with the master pods in the server?
The events. Basically, you get some events in there. So you have to say they're great. So the monitoring means you get a template for events and you have to create it yourself. And you just say, if this job goes over, obviously on this workstation, you can raise an event to service now.
I was thinking more about the actual, whereas we normally have event server problems with the master itself, not the technical master.
They're safe. So event driven.
Yeah, we'll come on to the dynamic side of things. But I just wanted to talk about how the REST API jobs work, because it is pre 10.2. So what we had to create was the logic itself within the job stream. So when a job stream runs against an agent, because everything within the AIOps application is accessed by this API manager, what we have to do is we have to run a trigger job, which makes a REST API call to post into the application. We get a response 200 come back, but within the response data is one of 4 statuses, which is success, running, error, or failed. Success is obvious. It goes straight and says, right, complete. Release the next job or the shadow job or whatever it is. But, and error as well, that goes as a ServiceNow event. If it's running, because some jobs within the application, you can post it and it will run for 2 to 3 hours. So what happens is that if the status response comes back as running, we have a polar job, which then does a get of that same URI and gets one of those responses back. So it goes into this loop of polling, and as it's saying running for 3 or 4 hours, whatever it is, and then eventually it'll come back and say success, error, or failed. Usually it's success, and then we complete from there. So we've had to build this logic within a job stream rather than in the job itself, which means that we're going to have to re-engineer the entire batch at 10.2. Good luck with that, Vince.
The issue we had was when it came back as run, it came back as an error. So now we have to change it. So every time it comes back as running, that's successful. But it's still interactive. When you look in the TWC console, you see success. It's not really, it's still running.
So we're looping using conditional dependencies. Should be a lot easier at 10.2.
Yeah.
Okay, so
All
that
the logic would be in the same job.
yes.
And that's just because of the way the current job type is worked.
Yeah.
Yeah.
Just write one script and execute the 3 steps script.
Yeah.
Script.
I know.
You don't want script.
Well, it would probably make life a lot easier.
Probably. Okay, and then we've got dynamic jobs, which was a requirement that, again, came out of left field, didn't it? It was halfway through the project. It's like, what about dynamic jobs? What are they? They're not in the original requirement. And what it is that on the mainframe, the operators can effectively run an ad hoc job or a set of jobs. But now, rather than those jobs executing sequentially on the mainframe, at some point it then runs jobs within IWA. You can't use shadow jobs for that, because what does the shadow job on the IWA world bind to? Because that job isn't there. It's not in the plan. So what we had to do was use a distributed server where we loaded the submit job script, so that a submit job stream script that was then invoked by the FTA that's connected to the mainframe. So that it ran the script that then made a REST API call to the master, submitted the job stream on that side, and when it completed, would then report back, and then the jobs could continue on the mainframe. But what we had to do was, because this jobstream.sh script that's provided on GitHub it's quite old now, it's been around for a few years. So when you do the submission, it asks, you need a master user ID and password in plain text. You can imagine what security said when they saw that. So what we had to do was rewrite the script and use JWT tokens instead. So we've had to generate a token in RWA and then embed that token into the script. Now, JWT tokens only last a year. So at some point, that token will need to be refreshed. And that's one of the things on the list in terms of the frequency in which that changes. But what, again, would be useful is if those scripts on GitHub were updated to use JWT tokens, rather than us having to rewrite it. So that's how we got over that problem. So everything we've come up against, we've found a solution. It's working most of the time. We have problems, we then have to debug it. It then starts working again and has become semi-stable.
A lot of that goes because of Elyzium, the documentation. Luckily, Elyzium have got the skills that you can ask them, they help you. Once they jump on their hooks, you know, the documentation has to be better.
Yeah. Okay. So, as I said, this is kind of warts and all in terms of the major problems that we've had. Some have been down to IWS, most of which haven't been, if you want my opinion. But we had a problem that lasted for months where we were seeing in the messages.log connection reset by peer, and shadow jobs would fail at that point. And it turned out to be a timeout issue on the database. Well, you got that as well.
Still getting those errors. We've had a case open with IBM for months.
So this is what I was saying this morning, because we had to get the Liberty team involved, and Alistair Nottingham gave us a debug thing that we had to put into Liberty so we could see everything that was going on. We then provided that file to Microsoft, who then made changes on the database side, and now it's working fine.
So they took the database.
Yes. It was the connection timeout on the database, because it goes through on their side, it goes through a gateway, and the gateway was timing out, not the database itself. The connection through the gateway was timing out.
And you retry straight away afterwards. Does it work?
Yes.
Yeah.
Yeah. So credit where credit's due. Microsoft were absolutely fantastic. At no point did they say it's your problem on your bike. They stuck with it. They said it could be our problem. We'll help diagnose where it is. If it's our problem, we'll change it. And they changed it really quickly. And then it all started working perfectly. But this problem went on for months, didn't it?
We didn't know what to
Yeah.
Yeah.
But eventually we got to the bottom of it. It was fixed. And now We don't see that at all, do we?
No.
Okay. The next one is there is a value within the Helm chart called FTA name. And what does that mean? Well, actually, it's the FTA name of the master. So by default, your master is called WA-server-0. And your backup master is -1. An FTA name gives you the opportunity to change that to something more meaningful. And it was your fault, actually, because you thought, oh no, I don't want this. I've got dev, pre-prod, and prod. So I want WA dev server-0, PP server-0, or PRD server.0. Great. With a master, that worked perfectly. As soon as we changed the replica set to 2, and we got the backup master, everything fell apart. And the reason for it, it turned out to be a bug with the labeling. And we had to revert back, take all of that out, redeploy, and then it worked fine. And that has been fixed in 10.2 or 10.2.1. The next one was a variable that was introduced and undocumented in 10.1 Fixpack 3. So by default, your key store has a password of default. And in the virtualized world, it's still the same, even at Fixpack 3. In the containerized world, they've changed it. So it's no longer default. And what happens is that there is a secret that's generated that's a random 8 characters. And when you're deploying using scripts and it's undocumented, you don't know about it. So when it was deployed, when Fixpack 3 was deployed, all the SSL certificates weren't loaded. So we got to the bottom of that. And that's why when Vince was saying before that we went 10.1 base and then 10.1.3, the reason for it is because at 10.1 base, it set the password as default. If the password was already there, it wouldn't change it. So when we put Fixpack 3 on, it then wouldn't use that 8-digit random name. And everything worked fine. Yeah, we kind of covered the next one off. The backup master goes pending and breaks the master service LB. When the pod goes pending, it will bind to the master's service. And it can go pending because underlying resources aren't available. So just like you would with a virtual server, it starts up and then it runs. Well, it can start up and then hang. That's what pending is. It hangs. So it's actually the underlying Kubernetes infrastructure that was the problem, but it meant that the IWA application wasn't available. No batch ran at that point until it was fixed. And then the last one, we're still having issues with using HTTPS connections from the mainframe to the distributed world, but that's because all the IBM documentation that's available, quite rightly, is based on RACF, not ACF2. And trying to make that change has been very difficult. Or trying to work out how to do it in ACF2 to date has not been possible. But that's not happening, is it? Simple. Yeah. Okay. So as you can see, it works. Everything it's supposed to do, it does most of the time. There are issues. And getting to the bottom of it, I won't do the customer quote. Can be problematic because you've got so many layers you've got Kubernetes, you've got IWA, you've got SSL, you've got all these things just layered on top of each other. And when it stops working, it's like, which bit's failed? You've got half a dozen logs to go to, loads of configuration files to look at. So debugging problems can be very difficult. But just like if you've come from a virtual server world, which is where I came from originally, learning about Kubernetes is great. Read the documentation, it sounds fantastic. In the real world, you need to understand exactly how it works in order for IWA to work correctly on it. And whenever you're in any meeting and somebody talks about whether it's an agent, master, whatever, in Kubernetes, tell them IWA is a stateful set application. That is requirement number one from our side when any Kubernetes project. And then in terms of lessons learned, read the GitHub repository, understand how the charts work, the templates, all those sorts of things, and then you can see the flow of what's actually meant to be happening when IWA is deployed. Don't just jump in and expect this to work. Because of so many layers, you've got to get it right. Plan, plan, and plan, and then deploy. Do you want to add anything else?
That's it really. I think the hard bit is determination, because you've got so many different teams. At the moment, you've got your mainframe, you've got, before we had mainframe FTA, you could access the mainframe using the FTA. It's easy to probably determine if there's a problem linking, so going active, you can check both ends. But here, once you start getting into Kubernetes, that's a different team. Then you've got your firewall, that's a different team. Then you've got your agent, that's a different team. Then you've got another file between your agent, which is another team. So when it's red up in the morning, you can't look at half the logs that you need to look at. That's the problem.
Right, I know I've overrun. Does anyone have any questions? Anything they'd like to say? Is anyone running IWA in Kubernetes today? Smart people.
So on that basis then, what you're saying in short is use virtual machines in the cloud because it's going to be easier.
No. No. What makes you think it's going to be easier? No. But this is what I mean by
more familiar. Shall I say it like that? More familiar.
If you plan it correctly, if you tell the Kubernetes administrators it's a stateful set application, this is what we need. We need to make sure that the volumes are persistent. We need to make sure that this is how you set up certificates, all the different pieces that are required, then yes, it works and it's reliable. But if anything shifts underneath the application, then recovery becomes very difficult. Just like if you had an unreliable virtual server, you'd have the same issues.
Yeah. So does the major SSL, the certificate refreshes, all that stuff, is that easier to manage from a virtual point of view?
Possibly, or you can use a separate secrets and certificates manager within Kubernetes. So if you're using a commercial one, then maybe life would be easier. I don't know. But that whole side at the moment in this environment is all manual.
Okay, because isn't there the concept of a certificate manager in 10. versions as part of the application stack? You can have that on a separate server instance.
Sorry, what's this in Kubernetes?
Not necessarily. No, it's a general question, really. I think I think there's a server manager. There's a certificate manager component that can run on a separate server.
In the Kubernetes world, there's IBM
in the virtual world.
Yeah, in the Kubernetes world, there is an IBM certificate manager which is free.
We use keyboards, don't we?
Yeah. But I mean, in terms of managing your certificates in general, even in a virtualized infrastructure, the certificates timeout, all those sorts of things, you need to make sure that that's managed. And that's really why I think maybe there needs to be additional things within the IWA product in order to manage those certificates, or at least report on them, and have an automated mechanism for updating certificates.
I suppose probably contain
Food for thought.
everything. I suppose if you had a virtual server, you could probably use like WinSCP. You could use like WinSCP, your VI. So at the moment, you have to be a VI. You have to know your VI inside out. Everything's your editing is using VI. With a virtual server, you probably could use WinSCP or an application to make it a lot easier. And obviously, there's lots of commands you can't use within containers that you can use on a virtual server. So problem determination will be easier on a virtual server.
Yeah, I mean, with a container, if you had all of the, say you had a Linux container, in order to have all the Linux packages, all the tools, all that sort of stuff, then the container becomes bloated. So you have pretty much a minimal install on Linux and then the application on top of it. So if there are operating system commands that you want to run, half the time it comes back and says not available. But that's a container issue, that's not an application issue. Sorry, Dean, did you have more to say?
No, it's okay. I'm thinking as you're speaking. So, because I've kind of always been of the view that when we do move our environment to the cloud, we'd probably have the masters on containerized environment because of theoretically, the maintenance ongoing would be easier because the update of a container is so much simpler. But what you've just described sounds like there's just as much admin, but in a different place in order to maintain this environment ongoing. So a virtual machine environment in the cloud is A, more familiar, and B, probably less of a learning curve for those without the knowledge.
Yeah, learning curve, I would agree. I mean, in this environment, it's particularly complicated because of the number of SSL certificates we use and the subscription ID and JWT tokens and everything else that's needed in order to lock it down. So management of that's the difficult bit.
But a more standard environment wouldn't be so complex and therefore less maintenance ongoing.
But I guess most customers going to the cloud would want to use SSL certificates, wouldn't they? So it's not going to go away.
Yeah.
No, exactly.
Hence the reason why the SSL management side of things needs an idea, which I'll do.
Is there any question of questioning the strategic decision to put master into?
I don't think we had a choice. I think it was a security. It was because of the REST API calls and the application needed that. There was no. I don't think there was any question of that. I was part of that decision.
Well, the agent had to run in Kubernetes because that's where the application is.
I wouldn't disagree.
And virtual servers or anything outside. Yeah, anything outside of Azure would have needed firewall changes, which may not have been allowed.
It does seem to have put a level of complexity in an already unstable environment.
Well, it's the art of the possible, isn't it?
Well,
because it works.
It's just
it does work.
You've got someone's made a statement, a strategic statement at some point based on, in practice, it's proven to be questionable.
I think we're on the microphone with TA. Still on.
Okay, I'm conscious of time. Was that it, Dean, or anything else?
Yeah, no, that's good. That's given me plenty to think about. Thank you.
Okay.